Okay, um, so we're gonna go past 9.3 and go to 9.4. Um, so 9.1, we talked about the Pythagorean theorem, which helped us solve for side lengths in a right triangle. And then we went to 9.2, where we talked about special types of right triangles, namely the 45 45 90 and the 30 60 90 triangle, and we talked about the cases or the ratios of their side lengths, how the ratios are always the same um, with any sort of triangle with those angles. Um, Now we're jumping to we're going to learn about some trigonomic functions. Um, so we'll be introduced to some new words today. Um, But let's analyze this triangle that we have right here. It's a right triangle, and we know that because we have this right here indicating it's a 90-degree angle. Angle A and angle B have to be acute angles because the sum of these three angles have to equal 180 degrees. And if this is 90, that means the sum of A and B have to be complementary, meaning that A and B have to add to be 90 degrees. um, and so that means they have to be less than 90. Both of them, the two of them together, have to be, both of them have to be less than 90 in order to add to 90 together. So that means they're acute angles. Okay, so we know that about the angles. Now, relative to acute angle A, um, we will name the side lengths of the triangle. First of all, in a right triangle, we always refer to this side as the hypotenuse. And this is always opposite to the 90-degree angle because it is the longest side. Now, relative to this angle A, so when we're talking about angle A, this leg over here, this leg BC, the leg BC is referred to as the opposite side. It's opposite to angle A. And the line AC is referred to as the adjacent side to angle A. Adjacent. Now, if we were talking about angle B, so if there was acute angle B, then AC would be the opposite side to angle B, and BC would be the adjacent side to angle B. And so this is how we identify or how we label our legs. The legs are labeled according to the angle that you are looking at it from. And this helps us define ratios between side lengths of triangles. And ratio is just a comparison. Okay? So there's what we call tangent. So the tangent of an angle, specifically let's say tangent, so this is the new word, tangent of angle A, describes the relationship in other words, it's the ratio of the opposite divided by the adjacent side. So the opposite side divided by the adjacent side. Okay? So if I was to describe tangent of angle A, we would define this as tangent of, so we'll just say, well, first of all, we usually abbreviate these. So whenever we say tangent of A, we abbreviate tangent by TAN. and then we write it as tangent of A. So that's how you would pronounce it, tangent of A. So looking at A, the tangent of A is the ratio of the opposite side. So in this case it would be BC divided by AC. BC divided by AC, because AC is the adjacent side. So just to make it a little bit more clear, so tangent of A is equal to the opposite, so length of leg opposite divided by length of leg adjacent. And we're talking about angle A. And this would be equal to BC. Okay. Now if we were talking about angle B, it would be different. Okay. So this is what tangent is defined as. So in this example right here, we have this right triangle with given side lengths. We want to find the tangent of both angle S and angle R. And write each answer as a fraction and as a decimal. So, right here, let's first start with tangent of S. So the tangent of S, so let's look at S. So this is angle S. We have to identify the side opposite to angle S. The side opposite to angle S would be 80 degrees. This is opposite. And so, tangent of S is equal to the opposite side, the length of the opposite side, which is 80, divided by the adjacent side, and the adjacent side to S would be 18. 82 is the hypotenuse. 82 is always the hypotenuse, okay? Doesn't 82 is hypotenuse always. And so adjacent side to S would be 18. Now you can reduce this ratio to be 40 divided by 9. And then if you were to put this into a calculator, you would get roughly that this is equal to 4.4444 if we're rounding to 4 decimal places. So that is tangent of S. Now the tangent of R, so let's look at angle R. So opposite to angle R would be 18. So tangent is the opposite side divided by the adjacent side. So 18 is its opposite side, and then its adjacent side to R would be 80. And this would be equal to 9 over 40. And if you use your calculator, you will get 0.2250. Okay, so notice that so tangent of S and tangent of R are just reciprocals of each other. Okay, so the tangent of this angle is the reciprocal of tangent of this angle and vice versa. Okay, so come down here and take a second and go through these ones and find the tangent of the acute angles in the right triangle. Write each answer as a fraction and as a decimal, rounded to 4 decimal places. So remember, I can do one of these. Well, let's do let's say number 3. Okay. So for number 3, we have acute angles A and C. So let's start with A. So let's take the tangent of angle A. So we have to do opposite over adjacent. Opposite to angle A would be 2, and the adjacent side to angle A would be square root of 2, because square root of 6 is the hypotenuse, so it has to be square root of 2. Now if you remember from the previous section, we don't like radicals in the denominator, so we have to multiply the top and the bottom by the square root of 2, thus multiplying this fraction by 1. and this would be equal to 2 square root of 2 divided by 2, because the square root of a times the square root of a is equal to a. So that would be the tangent of a. And if you are to use that in a calculator, well, first of all, we could simplify this just a little bit more, because we could cancel out the top and that right there. So it's equal to square root of 2. And then if you use a calculator for the square root of 2, you get 1.4142. Now let's find tangent of angle C. Tangent of C would be equal to the opposite side over the adjacent side. So opposite to angle C is the square root of 2, and the adjacent side is 2, because square root of 6 is the hypotenuse. And then if you punch this into a calculator, there's no more simplifying that you need to do here. So just punch it in a calculator and you get 0.7071. Okay. Now I recommend that you do 1 and 2 for practice. If you need answers, angle R, tangent of angle R here, it would be equal to 45 over 24, and tangent of angle S would be equal to 24 over 25. Okay. For this one, again, I recommend that you pause the video and do it, but if you're looking for solutions, tangent of angle J would be equal to 7 over 5, and tangent of angle L would be equal to 5 over 7. Alright, let's go on to this next example, finding a leg length. So it says find the value of x and round your answer to the nearest tenth. So you see here that we're given an angle. We're given angle 32, which is one of the acute angles in this right triangle, and side length L. So we want to use this tangent definition in order to solve for this missing side length. So I can set up the ratio of tangent of 32 to help me do this. So if I look at the tangent of 32 degrees in this image, so again, tangent is opposite over adjacent. Opposite to angle 32 is 11. Adjacent to 32 is x. Okay. Now I'm going to clear this up a little bit. So tangent of 32 is equal to 11 over x, right there. Now I need to solve for x. And if you guys still remember what we did last unit, we can cross multiply. So tangent of 32 as a ratio is the same thing as tangent of 32 divided by 1. And so we can cross multiply to get rid of our denominators, because this x is in the denominator, and if we're going to solve for x, we don't want it in the denominator. So let's cross multiply. So when I do that, I get x times by tangent of 32 equal to 11. Now, a lot of mistakes made by students is they make the mistake of multiplying, adding, and subtracting numbers from 32. But we can't do that because it is being operated by this tangent function. So this 32 has to remain 32. So if I do tangent of 32 times by 2, this does not equal tangent of 64. It does not work like that. Okay? 2 times by tangent of 2 would be 2 times by tangent of 32. So you'd have to multiply this tangent like that. These don't multiply together. So make sure you keep track of that, because students often make that mistake. Okay, now I'm still solving for x. So here I have to divide by the tangent of 32. Tangent of 32 is a specific number. Okay? It's a number. It's a real number. And so I can divide by it because it's pretty much saying like x times by some number. So if it's being multiplied by it, then I can divide by it. So I do 11 divided by the tangent of 32, and so x is equal to 11 divided by the tangent of 32 degrees. So now is where I can use my calculator, and you might have noticed these functions in your calculator. So here, first of all, if you have a calculator, you need to make sure that you are in the correct units. So eventually you'll learn about a different way to measure degrees. But basically for now, if you have a calculator like this or another calculator, make sure you understand that you are in the angle measurement of degrees and not radians. So I am already in degrees, which is good. So if you are in radian measure, if your calculator is set to radian measure, you might get incorrect answers. Okay, so I'm going to type in what I had before, which was 11 divided by, and if you look above 2 spaces above the number 9 on this calculator, you can see that I have a TAN button, which is tangent. And so I'm going to do tangent of 32 degrees. So when I do this, I get the value of 17.6. So x is equal to 17.6. Okay. There you go. So let's do some practice problems here. So we want to find the value of x. This angle given to us is 10. So I want to find the tangent of this angle because it gives me the opposite side to angle 10 and the adjacent side. Okay, so tangent of 10 is equal to the opposite side of it, which is 5 over x. And same thing, I want to cross multiply. So x times by tangent of 10 equal to 5 divided by the tangent of 10. So x is equal to 5 divided by the tangent of 10 degrees. So 5 divided by tangent of 10 degrees, and I get 28.4. So that is the missing side length. So go through 5 and 6 and set that up. If you want to pause the video and go for it, I recommend you do so. I will write down the answers if you want to make sure that you're getting them correct, but x here should be equal to about 26.7, and for number 6, x should equal 39.9. And for this last problem here, so it says that the triangle CDE, in this triangle CDE, measure of angle E is 90 degrees, and tangent of C is 4 divided by 3, and it wants us to find the tangent of D. So you see that we're not given a triangle, but we can draw a triangle. So draw a right triangle because it gives you that that angle E. So let's call this E. This is 90 degrees. And then we have angle C and angle D. So CDE. So it tells us that the ratio for C, tangent of C, so tangent of C is equal to 4 divided by 3. Now we know that the tangent ratio, tangent describes the ratio between the opposite side over the adjacent side, and now we're looking at this from the perspective of C. So tangent of C is equal to 4, so this side length has to be 4, and the side length adjacent to it has to be 3. Okay, so now that we know these angle measure, or these side lengths, we want to find the tangent of D. So tangent of D, if you remember that the tangents of both angles are reciprocals of one another. So technically we didn't even need to draw this picture, but if it helps, then it helps. But tangent of D would be equal to the opposite side of D, which would be 3, divided by the adjacent side to angle D, which would be 4. And there you go. Okay, so that should pretty much do it for the tangent ratio. In the next unit, we're going to talk about the two different other ratios.